All right, guys. I'm covering homework for tonight, page 157 and 158, question 1 through 8. So this is going to finish off with our linear equation with the three solutions: one solution, no solution, infinite amount of solution. Question number 1 says substitute 4 for x in the equation in the example and evaluate both sides of the equation. What is the result? Is it a true statement? So I'm looking at this equation right here, 3x plus 5 equals 5 plus 3x, and they want us to substitute 4 for x. So it'll be 3. I'm going to substitute 4 plus 5 equals 5 plus 3, 4. 3 times 4 will give me 12. 3 times 4 is 12. So it'll be 12 plus 5, which is 17, equals 12 plus 5, which is 17. So I get 17 equals 17, and it says, what is the result? The result is 17 equals 17, and is that a true statement? I'll tell them yes, 17 does equal 17. All right, so moving on to number 2. It says, choose any value for x and substitute it in the equation in the example. Evaluate both sides of the equation. Is the result a true statement? So this time, they want us to choose any value for x. For question number 1, they gave us 4. So I'm going to use 2. I'm going to put in 2 for x, so I'll be 3, 2 plus 5 equals 5 plus 3, parentheses 2. 3 times 2 is 6, so it'll be 6 plus 5. 5 plus 3 times 2 is 6. 5 plus 6 again, so it'll give me 11 equals 11, which is a true statement. So I'll tell them yes. So that's question number 1 and 2. All we're doing is just substituting. And you can tell that this equation, has infinite amount of solution because both of the coefficients are the same and the numbers are the same. Question number 3 says, how many solutions does the equation 3 parentheses x plus 2 equals 2x plus 14 minus x have? So remember, there's 3 types of solutions: infinite many solutions, one solution, and no solution. So I have 3 parentheses x plus 2 equals 2x plus 14 minus x. Remember, you got to get rid of the parentheses first. So I'll do 3 times x and then 3 times 2. 3 times x gives me 3x. 3 times 2 gives me 6 equals 2x plus 14 minus x. Now, as soon as I see this 2x and this minus x. I can combine like terms because they both have that variable of x. So I'm going to say 2x minus x, which is minus 1x, which would give me 1x. So I can just say x. And then I'm going to bring down that 14. Okay? Now, I can kind of stop right here and check. I see 3x and x. Those coefficients are not the same, so I can't stop. I need to keep going. Now you have 2 x's, but you're only solving for x, so you need to get rid of one of them. I like to get rid of the smaller one, so I'm not dealing with a negative number. This is a positive x. For me to get rid of this x, I need to subtract it. So that would be x minus x, which is cancels out. So 3x minus 1x will give me 2x plus 6. I'm bringing down that 6. And all I have left on this right side is 14. Now, I see a lot of you guys, you get stuck when you get to this part. I'm solving for x. There's 2 things with this x. There's this plus 6 and there's this 2. Try to get rid of the number that's just standing alone first before you start dealing with the coefficient. So I'm going to subtract by 6. And whatever I do to one side, I need to do to the other side. That'll give me 2x equals 14 minus 6. That should be 8. Now I have 2 times x, which is 2x is 2 times x. And I need to do the inverse of that, which is division. So I'm going to divide both sides by 2. And I'm going to get x equals 8 over 2. 8 divided by 2, which is 4. So I'm going to tell them x equals 4. And I really don't need... And then whenever you get x equals something, that means you have one solution. Anytime you get your variable equals something, that means you have one solution, okay? So we've dealt with infinite many solutions. Now we just dealt with one solution. All right, let's move on to question number 4. Question number 4 says use the equation to solve problems 4 through 5, okay? So I'm gonna go ahead and solve all 3 equations and try to see what type of solution they are, and then we'll answer question 4 and 5. Let's start with equation 1. Equation 1 says minus 4x minus 5 equals 4x plus 11, okay? Now, because this is a minus 4x, I have to keep solving it because the coefficients are not the same, okay? So I'm gonna add 4x to both sides to get rid of that. So that will give me negative 5 equals 4x plus 4x is 8x plus 11. Now there's I'm trying to solve for this x. It's just 8 and 11. Remember, start with the number that is not the coefficient. It makes it a lot easier. So minus 15 minus 11 will give me negative 16 equal 8x. And then I'm going to divide by 8 on both sides to get x equals negative 2. Okay? So that means this is a one solution. Anytime you get x equals something or a variable equals something, that is a one solution. So let's look at equation number 2. Equation number 2 says 4x minus 4 plus x equals 5x minus 4. Okay? I'm looking at this equation. Before I even do anything, I see that I can combine like terms, which is this 4x plus this x. I can combine them. So it's 4x plus x, which is 5x. So I really have 5x minus 4 equals 5x minus 4. I can stop right here because my coefficients are the same, which is that 5. And my numbers are the same, which is that negative 4. Whenever the coefficients is the same and your number is the same, you know that's infinite many solution. Okay? All right, let's look at the third equation. It's x plus 3 plus 2x equals 3x plus 2. All right? So before I even start again, I can combine like terms. This x and this 2x, I can add them together because they both have x's. So that's 1x plus 2x, which is 3x. So that's 3x plus 3 equals 3x plus 2. And I can see that my coefficients are the same, but my numbers are not the same. Remember for this last one, the coefficients were the same and the numbers were the same, so we had infinite many solutions. For this one, this coefficients are the same, but the numbers are different, so that means we have a no solution. All right? So question number 4 says, which equation has infinite many solutions? We know that that was equation number 2. Okay. Question number 5 says, which equation has no solution? We know that was equation number 3. All right. All right, we're almost there. Question number 6 says, Chelsea wrote the equation cx plus d equals 4 parentheses is 0.5x minus 5. What values can she use for c and d so that the equation has infinite many solutions? So with what we just worked on, we know that for an equation to have infinite many solutions, the coefficient and the number has to be the same, okay? So first I need to solve that right side, and then whatever I get for the right side has to equal the left side. So the right side is 4 parentheses is 0.5x minus 5. So I'm going to use my distributive property, which has this times this times that. 4 times 0.5 is basically saying what is half of 4. Half of 4 is 2, so I have 2x minus 4 times 5 is 20. All right? So for this to be infinite many solution, my left side has to be 2x minus 20 also. So that means my c is 2 and my d is negative 20. All right? So I'll tell them that my c is 2 and my d is negative 20. Question number 7 says, suppose that you use 3 for c and negative 20 for d in problem 6. How many solutions would the equation have? So I'm still using this same equation. Now I'm just using, they tell us to use 3 for C. So I'm going to put in 3 for C. So that'll give me 3x. And then D is negative 20. So 3x minus 20 equals 2x minus 20. All right. So they're trying to see how many solutions will this have. I'm looking at this and I see that the coefficients are not the same. So I need to keep solving. I have two x's. Whenever you have two x's like this, you want to get rid of one of them. So I'm going to get rid of this 2x because it's smaller. Whatever I do to one side, I need to do to the other side. And make sure you're going to the other side of the equation. So 3x minus 2x will give me x. I'm going to bring down that 20, and I'm going to bring out this negative 20 on this side. I'm going to add 20 to both sides, and I will get x equals 0, which means I have one solution. Okay? One solution, because remember what I said, whenever x equals something, that means you have one solution. We're almost done. Last one. It says the equation 3 parentheses x plus 2 plus 4x equals 6x plus 8 plus x has no solution. Rico correctly says that he can change one number in the equation to make an equation that has infinitely many solutions. What number should he change? What number should he use? Okay? So for us to figure out if he has no solution, first of all, we need to solve the equation. The equation was 3 parentheses x plus 2 plus 4x equals 6x plus 8. So I'm going to do my parentheses first. So that's 3 times x, which is 3x. 3 times 2 is 6, plus 4x equals 6x plus 8. I'm going to add like terms right here. So 3x plus 4x gives me 7x. Plus 6 equals 6x plus 8. All right. So I need to go ahead and solve this equation. I'm going to subtract by 6x on both sides. That'll give me x plus 6 equals 8 minus 6 minus 6, s equals 2.